All right, question 1. Consider this absolute value function. F of x equals x minus 2. If function f is written as a piecewise function, which piece will it include? So first off, let's recall that this is a V-shaped graph that's been shifted. That minus 2 shifts the graph to the right 2 units. We, of course, could use any kind of graphing technology. You could use Desmos to see that the graph is going to take this basic form. Notice the vertex is right there at the point 2, 0. All right, so I've made a makeshift graph here where we can see an absolute value function that has a vertex right there at the point 2, 0. But we want to take this absolute value function apart into two different pieces. And obviously an absolute value function is just made up of two linear equations. So let's take the blue part, the left side of that absolute value function first. And let's write the equation of that line in blue in slope-intercept form. First off, I should recognize the slope is negative because this line, if you read it from left to right, which is how we read lines, it is going downhill from left to right. And specifically, it's going down 1, right 1. Down 1, right 1. So the slope is negative 1 over 1, and negative 1 divided by 1 is just negative 1. And then the y-intercept, the b part of this equation, we can clearly see that it's crossing at positive 2. So we have that equation. Let's go and do the other one. And we'll do this one in purple. So we want to get the equation for this line now in slope-intercept form. This one we should recognize the slope is positive because this line is going uphill from left to right. We can see it's just going to be positive 1. We're going up 1, right 1. Up 1, right 1. So 1 divided by 1 is 1. Y-intercept a little trickier to come up with. We've got to extend an imaginary part of this line until it intersects the y-axis. So if we keep going in that same pattern of down 1 over 1, we will see that it crosses. I've not drawn my graph perfectly, but you can kind of see it where it's going to cross. It's going to cross right here at negative 2. You can probably see this a little more clearly in the graphing calculator. So for instance, if I have that graph in my calculator, and let's just say in another y equals, I put in just 1x minus 2 and graph it, you'll notice, see how it just graphs right on top of the right-hand side of that absolute value function. Okay, so we have our two equations, and I'll notice I see y equals x minus 2 here for choice D, and I see y equals negative 1x plus 2 here for choice B. So the answer is either B or D. Let's focus on the second part of that answer. So for instance, answer choice D is x minus 2, but it's only for when this rule occurs, when x is less than or equal to positive 2. So x is positive 2 right here. But this is saying we only want the piece that's less than 2. Well, to be less than 2, that would have to be this direction. And the direction or the piece that we have graphed is actually to the right of that point. So that's not the correct rule for that line. So it's not D. So just go ahead and verify that it is indeed choice B. We want that line, negative x plus 2, for when x is less than 2. So again, we just said x is less than 2 is when we're to the left of that point. which is exactly the piece that's graphed. So the answer to question 1 is B, negative x plus 2 when x is less than 2.